Hello friends, our today's topic is rectifiers with filter. Now in previous module we cover the rectifier concept. Now rectifier means what? It converts AC into DC. But if we check the waveform of half wave, full wave or bridge rectifier, we does not get a pure DC. What we can say, in rectifier it may get the pulsating DC. Okay, so see, if I am using, this is my AC waveform, so in half wave rectifier what we will get? I will get the output like this. So what we can say, this is not a pure waveform, pure DC waveform. What we can say, this is a pulsating DC waveform. Okay, so see, so this DC is not a constant and it varies with the time. Okay, so whenever this changing DC is given to any type of the electronic device, then it may not function properly and that may get damaged. So due to this reason, it will not applicable in most of the application. So if we use only the rectifier circuit, it not be may suitable. So what we can say, so we require a DC that does not change with the time. So to overcome this problem and to get a smooth DC, we will have a solution that is called as a filter circuit. Okay, so the energetic DC, it mainly includes both AC and DC components. So here filter is used to remove or reduce the AC components at the output. The filter, it can be built with the help of the capacitor, resistor or inductor, or the combination of capacitor, inductor, capacitor, resistor like this. The circuit diagram of the half wave rectifier using a capacitor filter is shown in this figure. Okay, so in this circuit, a resistor and a capacitor is used. So here the connection of the capacitor, it is in parallel with the load resistor. So see, if we consider this wave, this circuit diagram, just here what we include, we just connect one capacitor which is parallel with the load. Now how it works. So whenever AC voltage is applied to the circuit throughout the positive cycle, then the diode lets the flow of current through it. As we know, the function of the capacitor, it gives the higher resistive length to DC component as well as low resistive length to the AC component, or what we can say, it blocks the DC and bypass the AC signal. So the flow of current always choose the supply through a low resistance lane. So when the flow of current gets the filter, the AC component experience a low resistance and DC component, it experience the high resistance from the capacitor. So the DC components flow through the load resistor. So throughout the conduction time, the capacitor gets charged to the highest peak. Okay, so it will be charged to the highest, highest peak. Then after it charges to the highest peak, what will happen now? When the in negative cycle, when the diode is in reverse bias, so the charge capacitor, now it will be get discharges through this load. So it will be get discharges through the load. Again when next positive cycle come, again it will be charged to the highest peak and then it will be get discharges. So like this, if we observe, if we compare, so see, this is dotted line shows the rectifier output, and if we use the filter circuit, what we will get? We will get the approximately DC waveform. I will again explain. So see, when this is turn on, what will happen? This capacitor, when diode it is in on condition, this capacitor it will be get starts charging. So it will be charged to which value? It will be charged to this peak value. Once it will be charged, and when next cycle come, what will happen? Diode it is in reverse bias condition. Now it will be start discharging through this load. So we will get the waveform like this. So what we can say, we will get the waveform as compared to the rectifier output. With the help of the filter circuit, we will get the DC output waveform. Again same thing, full wave rectifier with capacitor filter. So here in the circuit diagram of the full wave rectifier, I am just added one capacitor which is parallel to the resistor load. What will happen? So again same thing, when positive cycle come, D1 is charged, okay, and what the capacitor now start charges, it will be charged to which value? It will be charges to the peak value Vm. Then during the next negative cycle, D2 will be now turn on, and now again it will be starts charges. So like this. So see, this is the comparison between the half wave rectifier output and full wave rectifier output. So here, because of this half wave, what happened? The negative cycle, there is no on of any diode. So this is the discharging time is greater. While in this C, the capacitor is charge, discharge, charge, discharge. So here this is the comparison between the half wave rectifier with filter and full wave rectifier with the filter output. Thank you.